Okay, on your packet, you guys have written, I have this typed in for you. You remember what H and K were? That's my vertex points. I need your help right now in finding what H and K are by transforming this one that's given into this one. Okay, I need to know where the vertex is. All right, so help me out here. What do you want to do first? And some people I helped out yesterday, so you know already, but I got to get Y by itself. You want to distribute 12? Distribute 12. Some of you may have divided by 12. That's fine. Do I want to FOIL this, though? No, I want it to look like this. It already looks like X minus H. Got it. All right, you guys keep helping me here. Keep helping me. This is the last time I'm going to ask you questions because tomorrow, it's your day tomorrow to work on whatever you want tomorrow. This is the last day I'm going to go over single problems with you. Get the Y by itself. What do you want to move over? 36, yep. So 12Y equals, there's not much I can do here except subtract 36 over here. Divide both sides by 12, yep. Go ahead, divide both sides by 12. I'm going to get Y equals, can I divide that negative 4 by 12? I cannot. What's in front here? What? Whoa. Okay, that's not going to fly. Okay, here we go. What's in front here? A 1. So do you see how it's 1 over something, 4p? That's going to be 1/12 right now. 1/12 x minus 4 squared, and then 36 divided by 12. Minus 3. What's your vertex now, guys? Pull the vertex off. HK. HK. What's my vertex now? My vertex is? What's in place of H? Is it negative 4 or 4? Right? Because it's X minus H. So what's in place of H right now? 4, comma, what's in place of K right now? Negative 3. There's your vertex. And you guys told me the vertex is halfway in between the directrix and the focus. So 4, negative 3. There it is. 4, negative 3. There's your vertex right there. It's halfway. Halfway. Ready? How many units is the vertex away from the directrix right now? That's at negative 3. This is at negative 6. How far away are they? 3, right? So I got to go 3 units in the other direction to find the focus. And if I go 3 units in the other direction, where am I going to be? Right on here, right? At 4 on the x-axis. And that point is 4, 0 for the focus. All right, vertex is halfway in between. I needed to transform it so it looked like my equation I gave you in your packet. Anything about this, or moving on to another one? Any of those other 3 we want to touch upon? Go ahead, Megan. 28. Thank you, because I wanted to do this one regardless if anybody asked, because it's been forever since we graphed a sine cosine function. All right, you read through it. It gives you the amplitude period and midline. Fine. I want to practice right now. Can you write the equation of this graph before we graph it? Write the equation that's got an amplitude of 3, period of pi over 2, and a midline of y equals negative 1. Keep that. You still got that sheet out? Still got our sheet out? Because I believe I put in... Yep, number 7. How to write the equation of it, except this is a cosine curve. Y equals a cosine bx plus c. What's a represent again? Amplitude. I don't need to find it. It was given. So I'm going to plug in 3. Y equals 3 Cosine, look in your packet if you need to. What's the B value? Frequency. How do I find frequency? I use what formula? The period formula. So ready? 2 pi, P equals 2 pi over B. Period in this one is pi over 2. You guys give me, how do you want to get B by itself? Cross, yeah, darn right. Pi B equals 4 pi. Divide both sides by pi. What's the by value of B here? 4. Go over, plug it in. 4. X. Anybody? We had a couple names for the C value. What's the C value again? We had a couple names for it. Shift and midline. Good. Shift or midline. I'm given the midline is -1. So -1. So there's the equation I'm going to graph. How many times do I have to graph it? 1 cycle. So you remember how we found the key values? Remember, I said, all right, get 4 little tick marks here. What should go there? You got it. You got it. Just throw out anything. Throw out anything, right or wrong. What value up here do I need to find those key values? Period is what? What's the period? Pi over 2. And you're breaking it up into equal parts of what? 4. So divided by 4, or I think I multiplied by 1/4. And that'll be pi on top and what on the bottom? 8. Okay, so I'm going to go every pi over 8. So that's where it's going to start. Pi over 8. And guess where it's going to end? Pi over 2, the period. And I know we got a little nervous here when we didn't, it didn't go by pi's or something easy. Count with me, ready? 1 pi over 8. Next one, 2 pi over 8. If you want to reduce it, go ahead. We're not going to mark you wrong if you don't. What's in between now? What's the last value I need? 3 pi over 8. And if you wanted, you go 4 pi over 8. It's pi over 2. All right. What other values do I need? I got the x's filled, so I got to do the y's. What values up here are going to help me find the range here from what to what? What do I need up here? Amplitude. So before I shifted, it went from -3 to 3 based on my amplitude before I shifted it. Where did I shift it, Lucas? Down 1. So now I got a new minimum and a new maximum. And they are -4 and 2. So go ahead, set up your y-axis, -4 to 2. However you want to do it. Megan, what curve are we graphing? Cosine curve. All right. Where does cosine start? Max, which is 2. So it's going to start at its max. Start at its max, went to its midline, right? Went to the midline, -1. Ended up where now? So max, midline, minimum, -4. Then went back to its midline and ends up at its max before it starts repeating itself again. There it is, one curve of this. And how about I graph that correctly? One jab, bud. One jab. Cosine curve, Arthur, the anteater. We went over that, correct? Yeah? When he's not flipped, anyway. Maybe if it's flipped, then it's an anthill. Anybody? No? Okay, never mind. Jokes are over. Sure this is not just a semester course? Too bad. We good here, Megan? Everyone else all right? I wanted to go over that one because it's been a while since we graphed a cosine or a sine curve. Okay. All right, I got 3 more to do with you. Tomorrow, you guys are going to come in. You can work with whoever you want. Pick an exam, pick your own problems, and see where it goes. Actual formula sheet out, number 34. Actual formula sheet out, number 34, and your calculator. Where's the Iceman today? Where's your boy been? This is ridiculous. It's almost like a whole week of review. Don't need it? What? Okay. You think it's legal? Or you think it's illegal what he's doing right now? Why do I ask? I don't know either. All right, take a look at 34. I don't know if anybody will read through it, and maybe you'll find out why I need your formula sheet for this one. Geometric series formula. Everyone see that on their formula sheet. Located geometric series, not sequence. Geometric series, which means I'm going to add all the terms up now. All right, add all these terms up. You can do this with me here. S of n equals a1 minus a. And I'm again getting this right off your formula sheet. Ready to go? All right. N years, so n's going to stay n. So that'll stay n for n years. First term. First year, 30 grand. 33 grand, sorry. Minus, first term again, 33,000. And here's where you may get tripped up. N's going to stay n. And this is, R does not mean rate. Anybody remember what it was for a geometric sequence? Common ratio, that's what you're multiplying by, right? And look, I wouldn't blame you if you plugged in 0.04. Okay, I wouldn't blame you. But guys, look at your calculator right now for me. Ready? She made how much money her first year? 33,000. Go ahead, 33,000. If you put 0.04 in there, go ahead, multiply 33,000 by 0.04. Is that how much she's going to make her second year? No, so I don't want 0.04 in here because you guys have seen that she took a big pay cut. All right, she's not earning any money there. All right, so if I'm not plugging 0.04 in there and you're still increasing, what should I be plugging in? Not 0.04, 1.04. Remember, 1 plus your rate going in there. All right, now go ahead and multiply 33,000 by 1.04. There, all right, now she's getting a little bump now. Okay, not by 0.04. If you multiply, you know what you're saying by multiplying by 0.04? She's taking a 96% cut in pay. That's what 0.04 means. All right, 96% cut in pay. All right, all over now. We can finish this now that we know that's 1.04. 1 minus 1.04. There's part A. And I'm going to leave you guys to part B now. Okay, I'll leave you guys to part B. How much total earnings, not what she's going to make in 15 years, total earnings after 15 years. So after her 15th year. About 660,000. Making sure we're all correct. Again, I would just, plug that sucker right into a fraction template. Can't go wrong. Any questions, issues? Everyone getting 660? Anything we need to help you with on your calculator? Okay. Can you get out the August 2016 exam now for these last two problems? So June, if you want to do some on your own, go ahead. But I'm done with that as far as today goes, and I'm going to August now. Number 14, the August exam, number 14. Still have your formulas you need to know but aren't on the sheet out. Number 14 in the August exam. Look at block number 13, please, on your packet. Look at block number 13 on the formulas that aren't given. Look at block 14 right now. 13. If you were here that day, I had you guys write in when a function is odd and when a function is even, I think. 13? 13? Okay. If not, you can write it. If you weren't here for that day, you can write it in somewhere else now. If it's odd, just a quick review. If it's odd, it's going to be symmetric with the origin. And if it's even, it's going to be symmetric with the y-axis. Okay, symmetric with the y-axis. So everyone ready to go to their calculator with me? Actually, I'm not going to do it. I'm going to let you look at it. We'll get the sine and cosine if we have to, because those I can't do my calculator unless it's in radian mode, and I don't want to flip around with modes right now. So go ahead, graph choice 3, x plus 1 to the third. X plus 1 to the third. Take a look at the graph. Okay. Well, first of all, does it even go through the origin? Does it go through the origin? So it can't be symmetric with the origin if it doesn't go through it. Right? There's no point over here through the origin. All right. It looks like it is. Watch. Ready? Here's the difference. Watch this. Ready? Let me do one that looks similar to it, but is actually an odd function, x to the third. Watch, ready? See my red one? That is symmetric with the origin. All right, so that's my red one is odd. All right, but the blue one is not, doesn't go through the origin. All right, doesn't even go through, so it can't be symmetric. All right, next one we're going to try, e to the 5x. Okay, now the question is, where's the E button? Two places. It's located one above your division symbol. Or you can go, some of you have an e to the x above your ln button. Either one you can use. Okay, either one. If you use the e to the x one, make sure you plug in the proper exponent, which is what for us? 5x. All right, graph it. Symmetric with the origin. What are our thoughts here? Symmetric with the origin? Absolutely not. No chance. All right, so I guess looks like we're going to have to rely on our ability to remember what sine and cosine look like. Where's sine start? Gentlemen, ladies, where's sine start? 0, then heads to its max, then heads back to 0, goes to its minimum and ends up at 0. All right. What happens in the other side? Same thing, right? Symmetric with the origin? Yep. So sine is an odd function because it's symmetric with the... Real quickly, cosine. I know we just practiced graphing this one. What type of function is cosine? Even. Cosine's an even function. Yep. Okay. Other questions from you guys? All right, we got one more together, and that's the big go right to the big dog one, 37. 37. I'm going to do part A with you, and then I'm going to let you and your group finish the rest, see what you can do on your own in your group. I had mentioned this the third period. I don't think you guys will have any worry about it, but I mentioned it in the third period. Please do not leave anything blank. All right, try to write something so you can get a couple partial credit points. Who knows? You never know. Also, please do not write us a letter about how bad you feel or how stressful this test was or a big question mark or a sad face with a tear. We don't care. Okay, unfortunately. And you know what? I'm not allowed to grade your test since it's a Regents. So I'm going to be in the grading room and Miss Lynch or Miss Wise has to grade that poor thing. And she's going to be like, is this your student, Carlina? I'm going to be like, I guess. Yeah, writing a little note about, oh, this is so bad. Yep, I wish I wasn't here. I'm never getting 27 points, maybe 2 points. Okay, we don't want to read that stuff. Okay, good. All right, here we go. Let's read about Seth. Hey, 16th birthday, $5,000. Look at that, huh? Somebody in my third period class just out of nowhere, she goes, you know what I got for my 16th birthday? A job. So I thought that was pretty good. 5,000 on his 16th birthday. He's going to invest it. He's either going to use option A or option B to invest. We got a couple questions based on those options. First question I'm going to do with you. Write an equation that represents option A and option B for n years. All right, so let's do option A first. These problems, because it involves a percent here, is just like our exponential problems I did with you yesterday. Just like it, except there's one slight difference. Y equals, what value did we always put first in our exponential problems? The A value, which was, oh boy, I remember this yesterday. This was painful. That's my original value, which is 5,000. So starting value times, is this growing or decaying? I hope it's growing if he wants more money back. 1 plus your rate. So 1 plus what rate for option A? Not 4.5. 0.045, yep. Raised to the, in this case, we'll raise it to the n because it's n years. No issues yet. Option B, we're going to run into a problem. And I don't know if you see the wording or not here. So option B, still starting at 5,000. 1 plus the rate. Now the rate changes to 4.6. Not a big deal. But here's the catch. Notice the wording. Compounded quarterly. Well, option A was compounded annually. Anybody know what annually means? 1 year. So I didn't need to worry about anything here. But now that option B is compounded quarterly, which is how many times a year? 4. And guys, that rate right now at 4.6, that's for the full year. You don't get that 4 times a year. So what I'm trying to show you is you need to divide your rate by 4, since it's being cut into equal parts of 4. And also, when you raise it now, it's just not going to be raised to the n, because you're not doing it once a year. How many times are you doing it? 4 times a year. So it's not going to be n, it's going to be 4n, because you're getting this value 4 times a year. Okay, quarterly, I divide it by 4. What if I change it to monthly? Divided by 12, 12n. All right. Semi-annually, maybe you'll see, which would be what? 6. But how many times a year? Twice, right? So that would be divided by 2. All right. You go by how many times a year, okay? Not how many months. Okay, everybody good on the... All right, I'm going to walk around and I want to check your answers for parts B and C now. So work with your group, talk with each other maybe. I know that might be new for some of you. Talk with your group. When you guys think you have and agreed on part B and C, call me over. Or if you have you're stuck, call me over.